The next section is about bonding, how elements combine with each other. Compounds are formed when elements combine due to a chemical reaction. Compounds are held together by chemical bonds. Once the compound is formed, it's difficult to get back to the original substances. This clip explains the role electrons play in making different types of chemical bonds.
Around 80 years ago, scientists began to realise that an atom is made up of a central nucleus surrounded by electrons, and the electrons are constantly moving. Moving in fixed paths called orbits, a bit like planets going round the sun. It was thought that the electrons control how the atom behaves. The electrons control the chemistry. Atoms were thought to behave differently because they have different numbers of electrons. This theory suggests that atoms are not held together like bricks and mortar. There's no glue. Atoms might collect together because their electron orbits overlap. This is one way the atoms are held together as molecules. Another way is for an electron to be transferred, to jump from one atom to another.
We saw two types of chemical bonding there. Covalent bonding is when atoms share some of the same electrons in their outer shells. Ionic bonding is when electrons transfer from the outer shell of one atom to the outer shell of another. First, more about ionic bonding. When metals bond with non-metals, they form ionic bonds. Let's take the example of sodium chloride, which we're all familiar with as common salt. A molecule of sodium chloride is made up of an atom of the metal sodium and an atom of the gas chlorine. Watch this clip to see what happens during this reaction.
This is sodium, so soft it can be cut with a knife. In seconds, the surface will begin to go grey as it reacts with oxygen in the air. But a vigorous reaction needs extra energy to get going. Heating the sodium up gives its atoms that extra energy and primes them for a reaction with chlorine. This reaction is a little chemical miracle. It turns two poisonous chemical elements into a vital cookery ingredient, sodium chloride, common salt. Zooming in, this is a chlorine atom squashed flat. With only 7 electrons in its outer shell, chlorine atoms are looking for one more electron to become stable. They're not fussy. They'll take it from any atom with an electron to spare. Sodium atoms make a natural partner because in amongst the cloud of electrons surrounding their nucleus, there's one electron sitting all on its own in the outer shell. The sodium atom is only too happy to pass that electron over to the chlorine, leaving the sodium with a positive electric charge, so it becomes a positive sodium ion. Meanwhile, the chlorine becomes a negative ion, and the scene is set for a chemical wedding. Because the bond between sodium and chlorine depends on them being ions, it's called ionic bonding. In practice, pairs of ions like this rarely exist on their own. When they gather together, they arrange themselves so positive ions are packed as closely as possible to the negative ions, and that's what gives salt crystals their regular shape.
In the clip, we saw that sodium and chlorine are both very reactive elements. Sodium is very reactive because its atoms have only one electron in their outer shell. And chlorine is very reactive because its atoms have 7 electrons, one missing from their outer shell. Sodium easily loses 1 electron to chlorine and becomes positively charged, while chlorine easily gains 1 electron from sodium and becomes negatively charged. Charged atoms like these are called ions, and the positive sodium ions and the negative chlorine ions are attracted to each other. That's why it's called ionic bonding. Large numbers of positive and negative ions stick together to form sodium chloride crystals, common salt. Next, covalent bonding, which involves the sharing of electrons.
Carbon is the king of covalent bonding. Look at a single carbon atom, and there are 6 electrons orbiting the nucleus. This means that only half the outer shell is filled. Carbon is some way off achieving stability. It needs 4 electrons from somewhere. But if a group of carbon atoms get together, they can share the electrons in their outer shells. That's covalent bonding. It means each atom feels as if it has a complete outer shell. But it doesn't just work for carbon bonding with other carbon atoms. Hydrogen will also bond covalently with carbon. 4 hydrogen atoms and a carbon atom make 1 molecule of methane, natural gas.
In the clip, we saw how methane is made, but covalent bonding is the basis of a huge range of hydrocarbon compounds. Remember, covalent bonding is the sharing of electrons between atoms, so they all achieve a complete outer shell. Nonmetals bond with other nonmetals using covalent bonds. Ionic bonding is the transfer of electrons from one atom to another. Metals want to lose electrons, so they form ions and ionic bonds with nonmetals that want to gain electrons. Here's a question about atomic bonding. A magnesium atom has 2 electrons in its outer shell. Explain the charge on a magnesium ion when magnesium forms ionic bonds with other elements. A magnesium atom has 2 electrons in its outer shell. When it reacts, it loses both of those electrons. This creates a magnesium ion with a stable outer shell with 8 electrons, and means the resulting magnesium ion has only 10 negative electrons, but 12 positive protons, so it's doubly positive, Mg++. There's more about atomic structures and bonding in the higher tier science programme. That's the end of atomic bonding.